I want to introduce one more problem that can be solved with search techniques, and this is a sliding block puzzle called the 15 puzzle. You may have seen something like this. So there are a bunch of little squares or blocks or tiles, and you can slide them around. And the goal is to get into a certain configuration. So we'll say that this is the goal state, where the numbers 1 to 15 are in order, left to right, top to bottom. And the starting state would be some state where all the positions are messed up. Now the question is, can we come up with a good heuristic for this? And let's examine that as a way of thinking about where heuristics come from. Now the first heuristic we're going to consider we'll call H1, and that's equal to the number of misplaced blocks. So here, 10 and 11 are misplaced, because they should be there and there respectively. 12's in the right place, 13 is in the right place, and 14 and 15 are misplaced. So that's a total of 4 misplaced blocks. The second heuristic, H2, is equal to the sum of the distances that each block would have to move to get to the right position. So, for this position, 10 would have to move 1 space to get to the right position. 11 would have to move 1, so that's a total of 2 so far. 13 is in the right place. 14 is 1 displaced, and 15 is 1 displaced. So that would also be a total of 4. Now the question is, which, if any, of these heuristics are admissible? Check the boxes next to the heuristics that you think are admissible.
The title is Sliding Blocks Puzzle, 15 Puzzle. On the left, it's a puzzle example, which is a 4x4 grid. Each block has a number on it. There's an empty block so that you can slide blocks to get a certain configuration. Now, we have 2 heuristic functions. H1 is the number of misplaced blocks. Now, H2 is the sum of distance of blocks. The question is whether these 2 heuristic functions are admissible.
H1 is admissible because every tile that's in the wrong position must be moved at least once to get into the right position. So H1 never overestimates. How about H2? H2 is also admissible because every tile in the wrong position can be moved closer to the correct position no faster than 1 space per move. And therefore, both are admissible. But notice that H2 is always greater than or equal to H1. That means that, with exception of breaking ties, an A-star search using H2 will always expand fewer paths than one using H1.
The answer is both H1 and H2 are admissible.